All right. After we learned how to determine what is the base and what is its corresponding height in any triangle, let's practice more on this matter, and then I'll give you some examples and let's find the area. Um, as you know, according to angle classifications, I have three kinds of triangles. I have an acute triangle, I have a right triangle, and I have an obtuse triangle. Let's draw the height for each of the bases of these triangles. First of all, the acute triangle. If this is the base, this is the base, I look at the opposite vertex and I draw a line that is perpendicular to that base. So this is the height and this is the base. That. In the right angle triangle, if this is the base, where's the opposite vertex? It's right here. If you want to draw a line that is perpendicular to that base, isn't this one of the sides? I already have a side that is perpendicular from the opposite vertex to the base directly, right? So the height is one of the sides. Let's try to rotate this triangle. It will be like this. Now let's consider this to be the base. Hey, you see, I rotated it. So I want to consider this to be the base. Isn't this the corresponding height from the opposite vertex and perpendicular to the base? However, if you choose this to be the base, you look at the opposite vertex and draw a line that is perpendicular. In this case, this is the base. Let me use another color. In this case, this is the base, and this is its corresponding height. Now I think things are more clear. Okay, now let's look at the obtuse triangle. If I want to consider this the base, how am I going to draw a line from the opposite vertex that is perpendicular to the base? No way. It is impossible for me to draw a line that connects here to here and it's perpendicular. So in this case, I draw a line that is perpendicular to the ground, let's say, to the same level of the base. Because I cannot draw a line that connects directly from this vertex to this base and it's perpendicular, I draw a line that is perpendicular and at the same level of the base. So in this case, this is the height and only this is the base. This is not part of the base. This is outside the triangle. This is not part of the base. This is the base of the triangle and this is its corresponding height. Let's solve a couple of examples to make things a little bit more clear to you. By the way, I want you to keep in mind that it is very important whenever I ask you to find the area for any shape, first thing you do is write the rule. That is very important. Okay. This is an obtuse triangle. If I tell you, okay, I don't want to draw this line. Okay, if I tell you that this is 6 centimeters, This is 14 centimeters. This is 10 centimeters. And this is, let's say, this is 5 centimeters. Okay, now this is an obtuse triangle. I gave you the size of 2 sides and 2 heights. Let's say some of you choose this to be the base, which is the 6 centimeters. First of all, I write area of triangle is base times height divided by 2. So if you choose this to be the base, the 6 centimeters, you should multiply it by its corresponding height. This is a height for the triangle, and this is a height for the triangle. Thus, which one do you choose? For this base, I look at the opposite vertex. I go down perpendicularly to the level of the base. So if you choose this base, you should choose this height with it. So you multiply 6 by 10 divided by 2, which is 60 divided by 2, 30 centimeters squared. Okay. Other students might say, no, I don't want to choose this as the base. I want to choose this to be the base. I say it's okay. As we agreed, any side could be the base of the triangle. So if you choose this to be the base, let me write the rule again. If you choose the 12 to be the base, you cannot multiply it by this height because this height is not for this base. Where is the opposite vertex to this base? It's this one. So this is the corresponding height to this base. So you multiply the 12 by 5 and you divide it by 2. In this case, it is 60 divided by 2, which is equal to 30. Think about it. Does it make sense that they both have the same answer? Although the measurements that are used in each of the formulas are different. Of course, they should be the same, Aslan. They should be the same. If you were doing a correct job, they should turn out to be the same because I am finding the area of the same triangle. So the area of this triangle is 30 centimeters squared, whether you chose this to be the base and this is its corresponding height, or you chose this to be the base and this is its corresponding height. And this is about it for the area of triangles. In the next video, we are going to discuss the area of compound shapes.